Hey guys, welcome. Yeah, so I'm going to show you a second method, elimination, which is like, a go-to method of mine. I like it a lot for solving systems. And yeah, so we worked out this first example using substitution and saw that the point of intersection of these two lines was -2, 7. Therefore, our x solution was -2 and our y solution was 7. And hopefully, elimination tells us the same thing. Now, as the name says, the whole purpose of this method is to pair the two equations, which is to add them or to subtract them, and in doing so, eliminate one of the two variables. So either eliminate the x's or eliminate the y's by adding them or subtracting them. And by them, I mean the two equations. Okay, cool. Now, if we add or subtract our two equations here, nothing happens, which is like neither x nor y goes away. So a third and final thing we're allowed to do is multiply either of the two equations or both by any constant that we want. But when we multiply, we have to multiply on both sides of the equal sign. So if we take the second equation, which is like -2x plus y is equal to 11, and it somehow suited us to do this, we're allowed to multiply both sides of the equation by like 3, for example. And when we multiply both sides by 3, the resulting equation is -6x plus 3y is equal to 33. That's not a 3. Okay, 33. Okay, cool. Now, you should know that this relationship between x and y is identical to this relationship. And linear equations in 2 dimensions mean equations of lines. So another way to say that is that this line and this line are the same line. So multiplying on both sides of the equal sign by any number does not change the relationship between x and y. That's why we're allowed to do this. Okay, cool. And so if we're going to use the elimination method, it will often suit us to multiply both sides of one of the two equations or both of them by a certain number. In this particular first example, we only need to multiply the second equation. And we need to multiply the second equation by 2. If we did that, well, we'd keep the first equation as is. So we'd have to write 5x plus 2y equals 4. And then the second equation, we're going to multiply by 2 on both sides. So 2 times -2x is going to make -4x. And then 2 times y is going to give us plus 2y right here. And then on the right side, 2 times 11 is going to say 22. Cool. And then now, what we need to do is subtract the two equations. After we multiply by whatever number we want, the goal should be to get the number in front of x or y to be the same. And here we got the number or the coefficient in front of y, that's the number in front of y, to be the same. And if the numbers are the same, but one of them is positive and the other is negative, then you could add the two equations and that will do the elimination. But if the numbers are the same and they are both positive or both negative, then you should subtract them and that will do the elimination. So we're going to subtract the second equation from the first equation. So when we subtract from 5x a -4x, we do 5x minus a -4x, therefore 9x. And then 2y minus 2y is going to be 0. So y is eliminated. And then 4 minus 22 is going to say -18. So we have 9x equals -18. And dividing by 9 here and dividing by 9 here, we find that x is equal to -18 divided by 9, which is -2. Cool. That's what we found x to be. And now to find y, replace x here with a -2 and then use this first equation to solve for y. Or replace x here with a -2 and use this second equation to solve for y, which I think is the easiest. Or you could also replace this x right there with a -2 and use this equation to solve for y, because remember, this equation right here is the same as this equation here. The relationship between x and y is the same in both, and they both represent the same line. Okay, cool. All right, so that's why you're allowed to use this third equation if you so chose. Like I said, I think this one makes sense since y is like kind of nice and simple and all that good stuff. All right. So you see this, but when I was going over the substitution example, I said that this was ready-made for substitution because the number in front of y right there is 1. Whereas like this was not convenient at all for substitution. But that's where elimination comes to save the day. And so let's look at this guy. 7x plus 2y is equal to -1, and then 5x minus 3y equals -14. Immediately you should notice that multiplying only one of the two equations is not helpful, right? You will not be able to eliminate x or y by multiplying one of the two equations. Well, yes, you can multiply one of the two equations by like a fraction and get there. But yeah, don't be clever like that. Okay, so what we're gonna do, or what we can do, is multiply the first equation on both sides by 5, and then the second equation on both sides by 7. And notice that it means the first equation starts with a 35x, and the second equation would also start with a 35x. So once we finish writing the two equations, the two modified equations, this guy and this guy, what we can do is subtract the two equations, and then x would be eliminated, right? But yeah, I don't want to subtract because we subtracted in this example, so I want to add. And this second system of equations is ready-made for adding to eliminate y. So instead of multiplying by 5 and 7, let's instead multiply by 3 in the first equation, and then by 2 in the second equation, and of course on both sides, and get these two resulting equations, which is 21x plus 6y is equal to -3, and then 10x minus 6y is equal to -28, and then now simply add. Instead of subtracting, now if we add, the y's eliminate, right? Or y is eliminated. And so 21x and 10x make 31x, and then plus 0y, and I won't even bother writing plus 0, and equals -3 minus 28 is -31. So we've got this. And then divide by 31 here, and divide by 31 here. So x is equal to -31 divided by 31, which is -1. Yeah, x is -1 here, and now you can find y by replacing x there using this relationship. You get it. Replacing x there using this relationship, or replacing x there and using either of the two relationships. Yeah? Cool. All right. So that's that. And now let's go on to the system of 3 equations and 3 unknowns. As you can see, I've already numbered them. And so what you want to do here is pair up, let's say, the first and the second equations, right? 1 and 2. So if we pair up 1 and 2, then we're writing and in this writing, it's clear that either z or y is easy to eliminate once we multiply one of the two equations by a certain number, right? And let's say that we choose to eliminate y. And notice we're pairing up the first two equations, right? Okay, cool. So to eliminate y, I need to multiply the second equation on both sides by 3. So the first equation would remain as it was, and that's this. And the second equation, once I multiply by 3 on both sides, would turn into 6x plus 3y plus 9z equals 0. And so then if we add the two equations together, then we get 10x, and the y's are 0, so plus 0, 10x plus 0 plus 10z equals negative 10. Wait, what? 10x plus 10z equals negative 10? That's saying 10x plus 10z equals negative 10 is the same thing as saying x plus z equal negative 1. Yeah? Cool. So there we are. So we can reduce this relationship to say just x plus z equals negative 1. And we got this relationship between x and z by pairing up the first two equations and eliminating y. Now we get this choice. Now we get to pair either equation 1 or 2, which we've used. We've used both. But now we have to choose one of the two and pair it up with the third equation. So let's say that we pair up 1 and 3. And let's try and do this in a different color. So if we pair 1 and 3, then 1 is 4x and then minus 3y plus z equals negative 10. And then 3 is negative x plus 2y minus 5z equals 17. So 1 and 3 make it difficult to eliminate y. Look, I'd have to multiply equation 1 by 2, and then equation 3 by 3, and then I have to add to eliminate y. That's too much work. So since we had a choice of pairing 1 and 3 or 2 and 3, once we paired 1 and 2, I'm going to go with 2 and 3 because 1 and 3, as you can see, is a bit more work than I want. But I saw if I pair 2 and 3, all I have to do is just multiply equation 2 on both sides by 2, and then I can subtract them. So 2 and 3, let me get rid of this. Remember, what we got out of pairing 1 and 2 is x plus z equals negative 1. Right here, we've summarized that. So now 2 and, sorry, I'll do it in white. We said pairing 1 and 3 is more work than we want, so 2 and 3. Okay, cool. 2 is 2x plus y. And then 3 is okay, so what we said is since our fate is sealed, which is since we created a relationship between x and z using 1 and 2, we have to again create a relationship between x and z. So we have to eliminate y again. And I thought that point was clear, but wanted to make it more clear. Anyway, that means we have to multiply equation 2 by 2. And doing so, equation 2 changes to 4x plus 2y plus 6z equals 0. 0 times 2 is still 0. And then equation 3 is in its original form like this, right? Okay, and now if we subtract the two equations, we could eliminate y. So if I wanted to add, I could just have multiplied equation 2 by negative 2 instead of positive 2, and then we wouldn't have to subtract at this stage, you'd have to add. Anyway, same difference. So now if we subtract, we get 4x minus a negative x, that makes 5x. And obviously the y's go away as desired. 2y minus 2y is none. And then 6z minus a negative 5z. 6z minus a negative 5z make an 11z. And then equals 0 minus 17. Yes, my z and my 7 look alike, but yeah, you get it. Okay, 0 minus 17 is negative 17. Okay, cool. Now look here. We just found another relationship between x and z, this time using equations 2 and 3. Let's write that right here. 5x plus 11z equals negative 17. But then solving this is like solving either of these two. It's solving a system of two equations and two unknowns. So I'm not going to do that. You know how to do that. Use either elimination or substitution, and you can solve for z or x using this relationship. And once you find z or x, obviously you can get to y by using either of these three relationships. Yeah, if you know Z and X, then you can get to Y. Okay, cool. So this is how elimination works, and I hope you got a lot out of it. And I'm going to show you two more methods for solving all three systems, namely augmented matrix or matrices in the next method 3, and then in our final method, Kramer's rule. Yeah? All right, cool. Keep watching. Take care.